In question 1, we have to use the appropriate properties to find the values of these two expressions that you see here. So while we can find the values of these expressions without using any properties, this question wants us to use properties like commutativity and distributivity and simplify our calculations to find those values. So let's do that. Let's start with part 1. In part 1, the expression is this expression that you see here, minus 2 by 3 into 3 by 5 plus 5 by 2 and then minus 3 by 5 into 1 by 6. So if you observe this expression carefully, you can see that it's made up of three parts. There's minus 2 by 3 into 3 by 5, then there is plus 5 by 2, and then there is minus 3 by 5 into 1 by 6. So essentially the expression has three terms in it, these three terms that I have boxed. And if you now look at the first and the third term, the first term has a 3 by 5 multiplier and the third term also has a 3 by 5 multiplier. So what we will do is we will combine these two terms, and to do that we will bring the third term to the second position and the second term to the third position. And we can do this because of commutativity of addition. So this will be our first step. Our original expression is minus 2 by 3 into 3 by 5 plus 5 by 2 and then minus 3 by 5 into 1 by 6. So we will take this second part, minus 3 by 5 into 1 by 6, this third part, and bring it to the second position, and we will take the second term plus 5 by 2 and take it to the third position. So we will interchange the order of these two terms. So we will get minus 2 by 3 into 3 by 5, and then we have the third term minus 3 by 5 into 1 by 6, and then we have plus 5 by 2. And why can we do this? Well, we can do this because addition is commutative. So because of commutativity of addition, we can do this. Now if you look at this expression that we've written, there's a 3 by 5 term here and there's a 3 by 5 term here. So we can take this 3 by 5 term out common from the first two terms, and we can do this because of the distributivity of multiplication. So let's do that. So we can write the common term 3 by 5, and then inside the bracket we will have minus 2 by 3, this term, and then minus 1 by 6, which is from the second term. So minus 2 by 3 minus 1 by 6, and then we have this plus 5 by 2. And the second step we could do because of distributivity of multiplication. Alright, now let's simplify this. So now we have 3 by 5 and then we have minus 2 by 3 into minus 1 by 6. So let's take the LCM and combine these two terms. Minus 2 by 3 can be written as minus 4 by 6, and then we have minus 1 by 6, and we have the plus 5 by 2 term. So minus 4 by 6 minus 1 by 6 is minus 5 by 6. So we get 3 by 5 into minus 5 by 6, and then we have plus 5 by 2. Now let's simplify this. So 5 and minus 5, this gives us minus 1, and 6 divided by 3 is 2. So we get minus 1 by 2 plus 5 by 2. And now the new denominators are the same, so we can simply add the numerators. So we will get minus 1 plus 5, or 4 by 2, and that will give us 2. So the value of the first expression is 2. Now I want to make an important remark here. In this first step that we did, we used commutativity to bring to exchange the order of the two terms. So we brought the third term to the second position and we took the second term to the third position. But you might say, hey, this was this number was a positive number, and then we were subtracting this number from 5 by 2. So basically, if you look at this part of the expression, the second and the third terms, this is of the form a minus b, where a is 5 by 2 and b is 3 by 5 into 1 by 6. but subtraction is not commutative. So how can we change the order? How can we bring the term B to the left and the term A to the right? So this might be a question that you might have in mind. But well, the thing is that originally we had A minus B, and when we interchanged the order, we wrote it as minus. So look at this second expression here. So we wrote it as minus B plus A. So A minus B, we wrote it as minus B plus A. And this is perfectly valid because here we are using the commutativity of addition. We can treat A minus B as A plus minus B, and we can change the order of the addition, and then it can become minus B plus A. So make sure that you understand this argument. Make sure that you understand that what we have done is completely correct. Now let's do part 2. In part 2, the expression is 2 by 5 into minus 3 by 7 minus 1 by 6 into 3 by 2 plus 1 by 14 into 2 by 5. So once again, we can see that this expression is made up of 3 parts or 3 terms. 2 by 5 into minus 3 by 7. Then we have minus 1 by 6 into 3 by 2. And then we have plus 1 by 14 into 2 by 5. So if you look at the first and the third parts, both of these parts have a 2 by 5 multiplier. So once again, we will combine these two terms, these two parts, and to do that, we will bring the third part to the second position and the second part to the third position, and we can do this because of commutativity of addition. So that is going to be our first step. So the original expression is 2 by 5 into minus 3 by 7, then minus 1 by 6 into 3 by 2, and then we have plus 1 by 14 into 2 by 5. So we are going to take this second term, this third part, and bring it to the second position, and we're going to take the second part and take it to the third position. So we will get 2 by 5 into minus 3 by 7, and then we will have the third part 1 by 14 into 2 by 5, and so we have brought this here, and then we will get minus 1 by 6 into 3 by 2, which is basically this part. And this we can do because of the commutativity of addition. Alright, now if we look at the this part and now the new second part, now these two have a common term of 2 by 5 and 2 by 5, so we can take out the 2 by 5 as a common multiplier. So we can write this as 2 by 5 into, and then we have minus 3 by 7 from the first part, and then we have plus 1 by 14 from the second part. And we can do this because multiplication is distributive over addition and subtraction. So we can do this because of this reason. And then the third part that we have minus 1 by 6 into 3 by 2, we can actually simplify it here only. So 6 divided by 3 is 2, and 2 into 2 is 4. So the third term is minus 1 by 4. Alright, now let's just write the reason here for this simplification that we did. So we used the distributivity of multiplication over addition and subtraction. Okay, now what we need to do is we need to combine these two terms, minus 3 by 7 plus 1 by 14. So that's easy to do. Let's take the LCM. 7 and 14 have an LCM of 14. So we will get minus 3 by 7 as minus 6 by 14. And then we have plus 1 by 14. And then we have this term minus 1 by 4. Now minus 6 plus 1 is minus 5. So we get 2 by 5 into minus 5 by 14. And then we have minus 1 by 4. Now let's simplify this. So minus 5 by 5 is minus 1. And 14 by 2 is 7. So we get minus 14 by 2 is 7. So we get minus 1 by 7 minus 1 by 4. And now we just need to take the LCM and combine these two terms. So 7 and 4 have an LCM of 28. And for this first numerator 1, we can write minus 4, and for the second numerator of 1, we can write minus 7. So we get minus 4 minus 7 by 28, and this is equal to minus 11 by 28. So the value of the expression in the second part is minus 11 by 28. And with this, we have completed both parts of question number 1. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.